I'm going to be solving physics sections 2.14 to 2.18, so let's begin. So question 1 says, which devices are present in the circuit diagram shown below? So the two light bulbs in series since they're next to each other, and two resistors in parallel since they're parallel to each other in the diagram. Connecting wires, like the wires connecting them. This question is simple. Question 2. Which light bulbs remain on if bulb 1 is unscrewed in the diagram below? So if you remove bulb 1, bulb 3 will be disconnected from the rest of the circuit, but bulb 2 will remain connected, bulb 5, bulb 4 and bulb 6 will be connected in this circuit, but this one becomes disconnected since we removed bulb 1. So only 1 and 3 will close and the remaining bulbs will remain on. Fill in the blanks with the correct name of each device. This is an electric cell or just a cell. These are memorization. These are symbols. We need to memorize the names of them. This is a resistor. Fixed resistor, fixed resistor. Resistor is enough, and cell here is enough. Or electric cell, it's up to you. This is a filament lamp, or just a lamp or a light bulb. There's many possible answers. But in the book, what does it say? It says, it calls this a filament lamp in the book. And this one, a fixed resistor. And the last one, just a cell. This is the book way of solving this question. Question 4. In order to measure the current through bulb A, the ammeter must be attached to points 4 and 5 in series with the bulb. If we want to measure the current through bulb A, it cannot be between 3 and 4 because the bulb is in between them. So it has to be it can't be between 3 and 4 because if it was between them, it would be in parallel. Like it shouldn't be between them. It should be after it or before it. So it's 4 and 5 and it's in series with the bulb. In order to measure the potential difference across bulb B, the voltmeter must be attached to points 5 and 6. See, because if it's between 5 and 6, it includes the bulb and it can be attached in parallel to it. Question 5. A 4.5 volt battery is attached to a circuit shown below. The light bulbs in the circuit are identical. So these all are identical. The current through the battery is 50 milliamperes. The current passing through the bulb 1, see if it's in series with the battery, it has the same exact current. But if it's in parallel to the battery, and since these two light bulbs are identical, the ampere gets halved since they both have to add up to 50. If they're identical, they use up the same amount of current. We divide by 2, so we do 50 divided by 2. So this one gets 25 and the other one gets 25. And bulb 1 remains 50 since it's in series with the battery. Question 6. 3 electric cells, each of 1.5 volts, are connected to form a battery. The electromotive force of the battery when the cells are grouped in parallel, the volt is constant, it's the same. But if the cells are grouped in series, you add them up, you add the volts. If they're in parallel, this is 1.5, this is 1.5, this is 1.5. But if you have them in series, 1.5, 1.5, 1.5, the total is 4.5. But here, it remains 1.5. the voltage is constant, here the voltage is additive. Here the current is constant, and here the current is additive in the parallel. The electromotive force of the battery when two cells are in opposition to the third one. They want the electromotive force of the battery when the two cells are in opposition to the third one. So these two cells are they're good with each other and they're in opposition with the third one. So it's positive, negative, and the third one is negative, positive. So it becomes 1.5 plus 1.5 minus 1.5. So it becomes equal to 1.5. Because مثلا for instance you took it as like this, and then you did this and this. These two complement each other and this one is opposite. So if you want to say, you can do 1.5 minus 1.5 minus 1.5. Okay, next question. The following are the tabulated results for the current through a resistor and the potential difference across it. Fill in the blanks. Based on the relation between the potential difference and the current, this resistor can be considered as an ohmic conductor. Since voltage is directly proportional to I in an ohmic conductor, V over I should be a constant, because we have R is equal to VI, so VI, the resistance, should be constant. So we do V, so we have 12 over 20, we have 24 over 40, we have 30 over 50. If you put this on the calculator, you should get 12 over 20, 0.6. 24 over 40, you should get also 0.6. 30 over 50, you should get 0.6. Since they're all 0.6, it means that this is an ohmic conductor. Now they want the resistance of this resistor. We got 0.6 milli ohms, since we used milliamperes and not amperes. So we just multiply by 1000, so we get 600 ohms. If the resistor's length is 40 centimeters and its cross section is 0.2 this unit, so the resistivity of the material which makes up the resistor is something ohms. They want the resistivity. There's a formula. Resistivity is equal to the resistance times the cross section area divided by the length. They want the resistivity. We found the resistance in part B. We do 600 times 0.2. We need to convert it to meter squared. So we have 1 millimeter is equal to 10 minus 3 meters. So if we make this power 2, so if we square this one and we square this one, we should get 1 millimeter squared is equal to 10 minus 6, since we multiply the exponents, meter squared. So we do 0.2 times 10 power minus 6. Then we divide by the length which is 40 times 10 negative 2. If we put this on the calculator, we should get 600 times 0.2 times 10 to the power of negative 6 divided by 40 times 10 power negative 2. You should get 3 times 10 power negative 4. Here they put 3.0, but they accept 3 without the decimal as a valid answer. Now you do question 8. The diagram shows two resistors in series, since they're in series, and a bulb in parallel with them. Like, you can obviously see that the bulb is in parallel, it's parallel to them, and the bulb and the two resistors are in series. They're not parallel since they're next to each other on the same line. Which of the following are true about measuring the electric current through an element in the circuit? The current is measured by an ammeter, and it has to be connected in series with it. These, you need to know them. It doesn't need any explanation. It has to be in series. Like if you have a filament lamp and you want to measure the current through this filament lamp, you add an ammeter either before or after it. Since in series the current is constant. The current is constant, so it doesn't matter if it's before the lamp or after the lamp. You put it in series. And if you want to measure the voltage, you connect it in parallel like this. So question 10, it's about the voltage. See? Wait. Which of the following are true about measuring the potential difference, which is the voltage, across an element in an electric circuit? The measuring device must be in parallel with it. The potential difference is measured by a voltmeter. The name of the device that measures the voltage, and it has to be connected in parallel with it, like this, volt, like this. It can't be in series, like this, it wouldn't work. Only the ammeter can be connected in series. Question 11. In the diagram below, the current through the resistor A is 1.1 amperes. This is 1.1, this is 0.3, and we know in parallel the current is additive, so we do 1.1 plus 0.3, we get 1.4. Question 12. In the diagram below, the potential difference across the battery is 3 volts. So this is 3 volts. And the potential difference across the bulb is 1 volt. So this one has 1 volt. And we know in series the voltage is additive. So we do 3 minus 1. 3 minus 1 is equal to 2 volts. So this one has 2 volts, this one has 2 volts. Because if this one takes 1 volt and this one has 3 volts, since 1 plus x is equal to 3, x is equal to 2, and this is in series with the bulb, and this one is also in series with the bulb. So this one has to be 2 volts, and this has to be 2 volts, and since these two are parallel, they have equal voltages. Like, it's obvious from the question as well. The potential difference across resistor A is 2 volts, and the potential difference across resistor B is 2 volts. Since if you cut this out, this is a series circuit. Then if you cut this out, this is another series circuit. 2 plus 1 equals 3. This is 2, this is 2. Question 13. Consider several electric cells connected together. The electromotive force of each cell is 1.5. The the electromotive force across this combination of cells is 3 volts. So this is 1.5. This one is also 1.5. This one is also 1.5. But see, these two, this this one is in opposition to the last 3, because the negative is with the negative. It has to be positive, negative, positive, negative. But here it's positive, negative, negative, positive. So this is negative 1.5. So 1.5 plus 1.5 plus 1.5 minus 1.5, it's equal to 3 volts. I remember such a question came in the finals. I got it wrong, it came in the prep list. I think the answer was 0, because I think it was like positive, negative, positive, negative, negative, positive, negative, positive, something like this. So I thought, no, like these two, 1.5, 1.5, I thought this one was minus 1.5, and since this one is with this one, I thought it's positive 1.5. But since these two are in opposite direction to these two, they're both negative. So 1.5 plus 1.5 minus 1.5 minus 1.5 is equal to 0. You don't count the last one as positive. I got confused in this question. Question 14. The ratio of the potential difference across a conductor to the current through it is called the resistance of this conductor. This is a formula. Like, define resistance. This is a definition and a formula, because we know R is equal to the ratio, any division, of potential difference, which is voltage, divided by the current. So R is equal to V over I, so it's the resistance. Question 15. The potential difference across an ohmic conductor of resistance 50 ohms is 12 volts. The current through this conductor to 2 decimal places. So we just said in the last question that R is equal to V over I. So we do 50 is equal to 12 divided by I. So we have 50I is equal to 12. So I is equal to 12 over 50, which is equal to 2 decimal places, which is equal to 0.24 exactly. The resistivity of germanium is 0.48 ohms per meter. A wire of germanium has length of 5 millimeters and the cross-sectional area of 1 millimeter squared. The resistance of this wire to 2 significant figures is 2.4 kilo ohms. So we have the formula. Resistivity is equal to resistance times cross-sectional area divided by the length. So we're given P as 0.48 is equal to the resistance, which we need to find, the cross-sectional area, which is 1 millimeter power 2. We need to convert this to meter power 2. We know that 1 millimeter is equal to 10 minus 3 meters. If we square both sides, we should get 1 millimeter power 2 is equal to 10 minus 6 meter power 2. So we do x times 1 times 10 minus 6 divided by 5 millimeters, which is 5 times 10 minus 3. So we do 0.48 times 5 times 10 power minus 3 divided by 1 times 10 power minus 6. You should get 2,400, but they want kilo ohms, so we divide by 1,000. We should get 2.4 kilo ohms. Question 17. This is just drag and drop. So this is a variable resistor. This is a cell. This is a lamp. This is a voltmeter. A variable resistor has a line through it. And yeah, that's it.